If you've been watching any of my videos, you know that I've been quite against using AI for software development for basically since it was a thing. However, for the past couple of weeks, I've been using Cursor to prototype an AI agent that we're building for one of our clients. And honestly, I might have been wrong. I feel like I've been leaving advantages and benefits on the table simply because I was too stubborn to use it. And so in this video, I want to tell you what's changed, how I'm using it now, and what are still the benefits and the disadvantages of using AI and Cursor for software development. And for context, if you don't know me, my name is Guillermo, and I'm the co-founder and CTO of a tech studio called 7 Sigma, where we build products for our clients. And the first thing is that the promise of AI is that it's a great junior engineer. And what I've learned is that if you treat it as such, it's actually very good and the bar is rising. However, when you fully trust it, you're asking yourself for trouble. There's been this whole idea of vibe coding and, handing delegating all the responsibility to the AI. I still believe that this is a mistake. However, when I behave with AI in a similar way as I would behave with any other team members, when I am the tech lead or the senior developer on a project, and I'm telling a junior engineer how to do things, which means instead of saying, hey, build me an AI agent, say, hey, we need to build an AI agent. Let's scaffold it in this way. We want these 3 modules. We want to put the prompts here, the tools here, and this and that schema, all the details, and then ask it to do it, and then go ahead and review what it's doing and point out the minor mistakes, which again, this has been software development for many years. Now you can do this with AI. And I found that when I behave in this manner with Cursor, which takes some effort because you wanna surrender all the responsibility. So you need to force yourself to actually review, send the prompt, and see what it's doing. Then it does quite a good job. I've been finding that if I tell it to do things and then go back, review the code, see what it's doing, see the mistakes, then I'm able to move so much faster. Because if I had engineers working on the project, I'd have to architect and send it over to the engineers, and then that feedback cycle would be maybe a day. They would have to go ahead and build it maybe a day, at the very best, a few hours. However, with Cursor, you get it in 5 minutes. Those 5 minutes still take me a little bit out of flow state in a way, but the feedback cycle is way quicker. So I've been able to prototype in a couple of weeks what I could have done in way more time before, simply because we had to use team members to do that. So that's the first point. The second point is that I found that there's a sweet spot on how much you want Cursor to take care of. I think if you babysit it too much, now you're losing advantages because, you need to be too explicit. And if you know how to code, you could have done that yourself and move a lot faster. So that's at a very small level. Then on the other end of the spectrum, you could go way too wide and give it very general instructions and then not do a good job either because it's not able to understand the broader context. However, there's a sweet spot, which I believe at this point is anywhere between junior and mid-level engineer, except he also knows a lot of, he has a lot of knowledge. He's just not good at implementing that at a big scale. So once you find that sweet spot, which again, I believe if you act as a tech lead and then you use AI as a mid-level or junior engineer, that's the perfect spot where you're able to move way faster. You can ask for things and provide feedback very quickly and iterate very quickly. But it takes a little bit to find that right balance on how much you want it to do. And with those key ideas, I think that in the future, we're going to be using this more and more. And I'm going to start changing some of my priorities as a CTO of our studio from training engineers to training engineers, but also having a set of processes and standards that ensure that AI code helps and moves things forward. We've always had a big collection of coding standards, best practices, and processes. And I believe if we take the time to put those into a way that AI can use them effectively, we'll be able to multiply our results and be way more productive. Now, before I wrap up, the caveat that I've been given all this time still applies, which is AI is simply a pattern matching tool. So you can't expect it to be smart. You just need to play with that capability to your advantage. So as I said, if we know what patterns we want to use or what architectures we want to use, we can just tap into AI to get into the patterns that it's learned and apply them right away. But ultimately, you need to be in control of what you're telling it to do and how you want it applied. And you always need to be responsible for fact checking. Again, same as any engineer. And if you don't have coding experience yourself, you don't have that experience, understand that those caveats still apply. So for very small projects, MVPs, proof of concept, probably not an issue. However, as the complexity of the project grows, you'll find yourself running into the same limitations as if you were working with a very junior engineer. So just be aware of that. But I believe that the bar is going to continue rising. And now it's at a junior level engineer. It's going to become a little bit better. I feel like there's still some sort of glass ceiling where there's going to take a lot of effort to get past. But using processes and implementing industry best practices is going to move this forward quite well. So that's it for this video. I'm going to continue making videos if I learn new things, and otherwise I will catch you in the next one.